I always picture AI like this, like and you set up a few features, and the new features are just feedback. They're feedback, and
Yeah.
they go and grow and grow and grow, and that's it.
So having something be autonomous, yeah, is like one of the pillars of AI to have autonomicity to things, autonomous cars, autonomous spacecrafts, autonomous whatever, things that can drive itself, take the decision basically for itself.
Exactly.
It's not a simple task, and what we see in these uh, commercial products, Tesla car, the Google car, all these stuff. Uh, yeah, for us it's truly autonomous, and it's a great advancement. But under the hood, I think it's just a lot of training and a lot of if-else statements.
Yeah.
Definitely. If you see a curve to the left, turn left. You know. I mean, but at the same time, it sounds easy. With just
Yeah.
saying there's a lot of ifs and
You see,
if and
it's
then.
not really. If I don't think it's like if you see a curve, then turn left, or if you see this kind of curve, then turn right. No, I'm sure there is a neural network that is self-adjusted and
Exactly.
self-trained for this stuff. But then there are special cases where they have to like if else the hell out of it, because the neural network always fails on that stuff. Because there are, I think, yeah, although driving, we understand it to be a universal skill and it's totally standardized, but I think there are difficult situations where, um, I mean, humans definitely overperform machine in this aspect. And the proof for what I'm saying for this is like somebody can say no, it's truly neural network and it's truly error prone and whatever. If that was the case, then where is the self-driving car until now, right?
Yes.
So this huge silence in the self-driving car scene right now proves that there are huge problems uh, within the safety and regulatory, let's say, procedures. Yeah, and Elon Musk, somebody mentioned Tesla. I think Daniel mentioned Tesla.
Yeah.
Like, I know other people in the group will hate me for this, but I really don't. On a personal level, of course, there's nothing wrong with Elon as a person. I like him. I like what he's doing for many things. But on the, let's say, if I start thinking of myself as a scientist or an engineer, I just hate the guy because he is playing this. I think this is my own personal opinion. He's playing this huge monopoly game where he's trying to force his product, his AI, deep learning product to the scene, just like Google, just like Microsoft. It's a fair game on their level, but on the consumer level, it's not a fair game because there are some things that like we like don't force me to learn your tool and say that it's the best tool, because all what you've did is actually pick up the tools that were already open sourced and then claim them to yourself. That's what you did. And this goes for Google and Microsoft and all these new deep learning commercial tools, I mean open source branded tools.
But Mo, when you were studying your master's degree,
Hmm.
and did you discuss these questions, like the questions we get here, and we get no response about it?
uh, yeah, you see, I
But I
did.
would really like to know. I'm sorry to interrupt you, because I would really like to know what is your your position on this, or the position or the on the experts of the field, so to speak. Because when I asked these questions to my teacher, the one I told you earlier,
Mm-hmm.
he came up with this complex response in which I didn't quite follow what he was saying.
Yeah.
Maybe he was trying to persuade me in a way that I didn't understand it, or he actually didn't know the answer. So that is the most thing I question always about AI. Is it really
Yeah.
a future, or that's it? It's just Google, Microsoft trying to sell stuff.
Yeah. Yeah. I totally. So here is what I respond to that. So in every domain, let's say in every scientific domain, whether it's AI, whether it's uh, any subdomain of computer science in general, or even non-computer science, biology, whatever, the world is divided into two main hemispheres. Let's say there is academia, there
Mm-hmm.
is research that has been done in universities, academic institutions, and you know things under the realm of education. And there is the other hemisphere where things are running under the realm of industry and capitalism and profit.
Oh, I'm sorry. I'm really, really sorry.
It's okay. So the thing is,
Hello.
although
Sí.
both
Hello. Continue.
although both hemispheres are trying to solve the same problems, both have different intentions, different motivations to what brings the world, or what bring advancement to the world. When I did my masters, I didn't definitely it's not as easy as, hey, I'll sit down with my doctor and or my professor and just ask him, hey, what's the answer to life, and he will just give me the answer to everything. It's definitely not that, because there's a certain type of politics that
I have to
that you
take
have to
that.
play. There's a certain type of politics that you have to play in academia, and definitely there's a certain type of politics that you have to play in industry. And for you to get an answer to like the latest advancements and the big questions, you have to be like, well, first of all, well researched and very prestigious. And by prestigious in academia, you have to have like many papers, a lot of recognition, and basically a long list of people who are sending you emails and CCing you in emails. So this is how you get prestigious in academia. You have to be well recognized in your domain. And
Right.
in the industry, it's the same thing. I'm not really sure how it's manifested. I mean, pretty much I think you have to have lots of money. And but the thing is, it's not always an let's sit down and discuss this and then tell me if you've got an answer, or tell me the answer. It's never like that. Usually when you approach a professor or a highly ranked professor, first of all, it takes you a long time to actually grab him and sit down with him. And even if you sat down with him and you ask him, it's not a straight answer to a question. It's more like, hey, read this book or go. They definitely give you like in my case, my professor was very smart. Hiroaki Saito is very, very smart. And I always get an aha moment with him, but it's never an aha moment when I sit down with him. It's more like I sit down with him and he tells me, hey, check this paper. And then he just leaves. And then
Mm-hmm.
I'm like, oh, I hate this guy, whatever, whatever. And then I read the paper, and then I'm like, and this happens always with me. When I first read the paper, I understand 0%. I understand nothing. It's totally gibberish. totally gibberish to me. I have no idea what the paper is about and who wrote the paper and what's going on. I just don't understand anything. And then when I read it again, I start, oh yeah, I get this. And then I read it again and again. And by the time I fully understand the paper, I get this epiphany where I'm like, oh my God, my professor was right. And
Yes.
he pointed me exactly to what I needed to know. So this is in academia, I guess this is how you advance, this is how you get the answers. It's not mostly yes or no questions or yes or no answers and hey, just do this and you'll be fine, or just read this and you'll be fine. Because when your professor points, if a good professor points you to a good source and you read it and you get an epiphany moment, it's not a true answer. It's more like it's a new question to another kind of problem.
Right.
Hey, Cow.
Hello. Yeah, something like that.
How are you?
Fine. So, who's there? Daniel and?
Daniel and Khalif, but I think Khalif is dropped.
Yeah. Left. This is Daniel here. Nice to meet you.
Nice to meet you, Daniel.
So we were discussing AI on the modern scene, what's happening today, and
That's a good
Google.
topic.
Yeah, good topic. Google's announcement to its DeepMind AI tool, and that its tool has found its way through a 3D maze by sight. And this was on The Verge, and everybody's so excited, like, wow, that's like a cool advancement, whatever. But what I'm saying is, that's not cool advancement at all. That's a PR move. Actually, we could do that. We did do
Yeah.
that a long time ago. So nothing new there.
Well, not only that, right? The Go
Yes.
winning champion or something.
Yes, true,
It's
true,
also
true.
just PR.
Yes, true.
Even if it is a move.
Yes. Yeah, it's more like AI. What I'm saying is AI is now getting more political. So everyone is like claiming a part of it and saying, "Hey, we do this better. No, Google does this better. No, Microsoft does this better." Everybody's trying to take a bite out of AI, which is an open public domain. So don't convince me that, you are the god of this realm because you've solved a 3D game. What I'm more
Well,
concerned about,
even if it's not public,
uh-huh.
even if it's not public domain, or even if it's not being openly developed, as long as you show it to the world, anyone can easily go and copy. There's no such black box out there that anyone can make alone anyway. So
Yeah, true. But what I think is they're trying to, create a community around their DeepMind tool. Because
right,
if I put my efforts
TensorFlow,
now,
right?
and I think TensorFlow is their main open source tool. TensorFlow. And DeepMind is the product, I think.
Yeah, DeepMind is the company that they bought, and it's kind of, you can't say it's a product, but it's like a section.
Yes. Yes. True. It's a research lab.
Yeah, precisely.
Yeah. What I'm actually more concerned about is something that might not be AI related directly. It's more about, and I know this is not subject for AI, but it's net neutrality. And it's kind of scaring me now
Well,
because
it is. It is. It is a topic.
Mhm. It is a topic, and it's a scary topic because actually, according to what I understand, is that laws have been made on 2015 to protect us against ISPs data capping our uh, our bandwidth for
Yeah.
let's say if you have a company and I have another company and your company is more powerful than mine, then the data bandwidth coming from your side is more powerful than the data you're streaming is more fast and reliable than the data I can stream. It's just because you are paying ISPs more money. So it's not a plain playground anymore. Whoever is powerful can dictate the market to his benefit. And
Well, that was bound to happen because the movement started and it moves a lot of money, so it would happen anyway. Now the question is, can we undo it? And I think we can. I think this is not going to last too long because it's clear that it's going to be harmful to the internet.
you see, according to my understanding, net neutrality is actually doing nothing to the internet and keeping the internet the same, as opposed to
Yeah,
changing anything.
yeah, it is. It is. But as a movement, when you say net neutrality, you also bring the other side of the coin. So whatever you call it, just the movement needing to exist, such a net neutrality movement is a bad sign. So
Yeah, by itself, it's a bad sign that we are discussing this subject in the first place.
yeah,
Yeah, and the thing is, laws have been made, and they dictated that net neutrality will benefit us as a consumer by not changing anything. But on the other side, big ISPs are actually defying these laws and actually data capping already. Verizon is one example. They just recently uh, provided some like options for the consumer where, hey, if you want streaming up to 1 gig, then you pay this. If you want to up to this, then you pay this. And it can sound benign, but it's actually very, very mischievous.
yeah. It's the whole Snowden case, right? It's not only net neutrality. It's also what the government do with the data. So it's actually all about at some level about data liberty.
Yes, absolutely right.
And when you go to privacy, it's just one way of having your data the way you want it. So they're all in the same box somehow, and it's really this is a much harder topic than AI.
Yeah,
We
I
can
think,
solve AI, but we cannot solve this before the singularity. No, we can't.
or maybe we can solve AI and create an AI that will solve this for us, since it's
That's the whole idea.
really interesting stuff. Uh, yeah, it's like I'm just concerned for my own virtual good being, you know. I want to I don't want anything to change. Internet is just perfect. I want to be able to do anything, read anything, download, maybe not anything, but according to the law, I should be able to download anything.
Well, it's a little bit like the radio was in the beginning. Anyone could just pick up a radio transmitter and be a radio station.
Uh-huh.
And things starts to get big, get a lot of production, and then if a consumer doesn't see enough production in it, it doesn't have enough value to be consumed.
Uh-huh.
And then even if it's free, suddenly it becomes in the hand of whoever has more power to make it a good production.
Yes.
So
Yes.
that's a problem right there with internet that's happening already. And even if net neutrality does victory, does win upon whatever is fighting it, you're still going to have that problem. It still needs some kind of regulation, to not get abused by a monopoly, because it's really a human tendency to go that route for some reason.
Yeah, as humans, we always tend to exploit whatever
Yeah.
technology is there. That's very true.
Exploit everything.
Yeah. Apparently it's a very difficult problem. For us to control it, we have to control human intuition.
Yeah.
But then on another side, I've shared a video of this robot called Eldrick,
Hold one.
the one that sank the hole in golf. Have you guys checked it out in the Slack team?
Yeah, I was just watching it.
How about this? Yesterday, a robot.
Right, nice.
It's interesting, like this Eldrick robot just synced it in one shot, and it's a 16 hole,
Yeah.
so
It's not too hard to picture how that's done, right? But
apparently to like golf experts, this sync drop is not that hard.
yeah,
You know, Tiger Woods famously got one in 1997, and Italian pro Francesco Molinari also did the same. And now Eldrick. Eldrick the golf bot.
Hendrik. Where that name came from?
Yeah, I'm trying to. It's Launch Directional Robot Intelligent Circuitry. That's a one big name. So, so it's a brainchild of pro golfer Gary McCord
A child.
by Golf Laboratories.
I have no idea what that means.
So basically, the name, it states the name, Launch Directional Robot Intelligent Circuitry. And
Right.
the one who created it is a pro golfer, Gary McCord, and he has a golf laboratory, actually, that researched how to build Eldrick. And Eldrick spends its days testing club designs. So it's actually training on the designs of golf clubs and dictating which ones is better.
That's interesting. The robot came out of manufacturing golf clubs.
Yes. Yeah, because for them to actually like test the club, they have to make the robot actually swing, right?
Yeah.
Yeah, so I understand why it's interesting for you and even me, because it's actually we should rather than test the club, we should test how accurate it's shooting, right?
Yeah.
And for us to test how accurate it's shooting, we have to test the club. It's kind of the chicken and egg problem.
Yeah. But they solved it. They made it.
Yeah. So the golf bot is capable of driving balls at up to 130 miles per hour, 5 miles per hour faster than Tiger Woods in his prime.
Wow.
Yeah.
Wow. Actually, that's the least impressive part.
Yeah.
Right? That's the one thing that you expect from robots is to be stronger.
Yes. That's very true. That's the least impressive thing.
Yeah.
But and the most impressive is where it's worst at. So the aim is not perfect.
Yeah, accuracy. Yeah.
So it takes 5 tries for the robot to successfully make that shot.
Well, that's awesome. Still, 5 tries.
Yeah, so basically the article says that at the end you still won't find many human golfers able to do the same unless they are thunderstorm.
Thunderstorm.
Yeah.
What's that?
Yeah, like I think what they mean is like unless you're a rock star golfer.
Oh, like okay. I thought it was like a perfect storm or something like that.
Yeah, maybe.
I don't know. Some kind of slang. And you know, and you were talking about the chicken and the egg.
Yes.
And I stumbled upon such a realization when I found a bug on Mario X.
Uh-huh.
And when I fixed the bug, I noticed the program was running almost or even exactly as expected from the origin, the Seth Blink game.
Mm-hmm.
And whenever it hit a wall or stopped for 3 seconds and the fitness doesn't go up, it would reset and go back to the beginning. So it would just basically kill itself and start again. You know, a new life.
Mm-hmm.
So every time the species would go up, it would kill itself and start again. This means basically that this evolution that way is always the egg that comes first, because the evolution only happens when the species changes.
Mm-hmm. Mm-hmm.
And in this way, I gave it just one shot. I left it running for about 100 hours and 100 generations, coincidentally.
Uh-huh.
And it never finished the first stage. You know, there is some random luck involved, but it never did. While on Seth Blink, he managed to do it on the 90th generation, so 90 generations. I don't know in how many hours. His machine is certainly faster than mine. And when I removed the bug fix and introduced the bug again, which is the species continue to go on no matter what. If it stops in one place and the fitness doesn't go up for too long, it doesn't matter. The species keeps changing and randomness keeps happening, and mutation and genetics happens right there, right now, without dying back to the beginning. So then we're introducing the chicken comes first, as
Yeah.
well as eggs. It doesn't matter. It happens anywhere. And when that's the scenario, for 2 times, at least twice, it could finish the level in just 8 hours, less than 30 generations.
Mm-hmm.
So I don't know for you, but for me, whenever I thought about science and genetics, I could never understand how chicken or egg comes first is even a question. Of course, it's always the egg, right? Because that's when genetic mutation happens, when you cross over the chromosomes. Nothing else. If it happens anywhere else, it's cancer.
So what you're saying is the egg comes first because it's the child of whatever was crossed over to,
Yeah.
but then what this crossed over to? What?
Right. 2 chickens. So it's not chickens. It's something before chickens. So whatever. A dinosaur cross another dinosaur, and then there's a chromosomes, and then that's where most of, or maybe all, as far as I knew, all genetic mutations happen there on the crossover. So
Yeah, let's say that's here's a question. Let's say that only chickens actually inhabit the earth. Okay?
right.
Just hypothetically speaking.
All right.
So how did the first egg come?
Oh, I see what you mean, but that's the whole point of evolution. Where the chickens come from, right?
Uh-huh.
every chicken, every live being, everything alive comes from some kind of egg, some kind of zygote, some kind of minor evolution of itself.
Embryo, yes.
Yeah, and then the embryo, and the embryo comes from something that's one generation before. So that's why the embryo, the egg, always comes first.
Mm-hmm.
In evolution at least.
Yes,
But
yes, I see your point. But
but
I'm
in
sure.
Mario,
Yeah.
in Mario, what I did realize was if both chicken and eggs come at whatever random time, evolution happens faster, much faster, and the intelligence behind it is also much more intelligent because it can finish the level faster. Much faster if you consider all things.
Mm-hmm.
So, and then I thought, well, maybe in biology that's also true. Maybe cancer, just like a malfunction, is actually a form of evolution, and maybe there is some chicken that happened, out of the blue. It was a chicken, then it's not a chicken anymore. Now it has something else, and that's the gene that went through to the next one. I don't think we have any evidence for that in science, but maybe that's something there,
Yeah. Yeah, I understand your point. Very interesting. Unfortunately, I'm not smart enough to refute your thoughts, but I'm sure someone smarter can actually prove you not
Wrong.
wrong, but argue with you on the egg
I hope
versus
so.
chickens.
I want to find someone who can prove me wrong. I love to be proved wrong. That's when you learn.
Hmm. The only thing I can add to that is you're right, since actually everything comes out of an egg. Even humans, we are embryos at the very first thing, right?
Yeah.
So yeah, there is an egg in everything. Like yeah, we might be born, but we're actually eggs.
Alien. So I'm going to a forum that's called Daily What the Fuck,
Yeah.
and then there was some kind of hug day or friend day or something,
Yeah.
and the people there they're very they love what the fuck images and whatever and random stuff. So for the friend day, he got an alien pet made of fluff teddy bear, like a teddy bear, and put it on the face of a child, right, like this.
Uh-huh.
And took a photo, and then that's the friend hug day. An alien eating your child. Oh man, so out of context.
Um,
Look at this. I'm gonna throw a link there on Slack. Guys
so
say,
yeah, Google recently its AI application won over the top Go player. This was unprecedented, right?
which one?
The Google's victory over a top Go player.
Right, yeah. And yeah, that's the PR movement right there. Because even if it is unprecedented, nobody doubted that it was possible because it's just big data. It's just crunching data,
Yeah.
more and more machines, and that's a minor step forward.
No, I think it's much more than that. It's more like a neural network that, yeah, of course there is crunching data, but there is intelligence in how it plays. So it actually provides new gameplays, not specifically the same patterns of which it has trained. But then the thing is, first of all, DeepMind is not only a laboratory but also a program.
Right.
So and the Go player is, yeah, it's a top Go player that it won against, but it's not the world champion. The
Right.
world champion is the actually the championship game is going to start on March 9th.
So
And
1 month from now. Yeah, the machine's gonna win, of course. If not today, next year at most, even less than that. But it's not really a step forward unless it's the same DeepMind algorithm that can also do chess and I don't know, win at war. The board game.
Yes. You mean it's not configured for just to play Go alone?
Yeah, exactly. Yeah.
Yeah. It might be the case. We really don't know, because actually the chess problem has been solved before. I mean, we've won against the champion, the world chess champion in 1997.
Yeah.
Yeah, so that was a long ago, but because Go is such a, the rules are complicated, so they had to yeah, it's kind of weird how like this big time shift or time gap between 1997 and almost 2017, so a 20 years gap just
Yeah.
to beat the top player in Go.
Yeah, because Go is much more complex computational-wise, because it's a lot of pattern recognition and it's a bigger board. So maybe that's the next question would be how big of a board can it win from the top player? Because a top player can win in any kind of size of board. There just happens to be one standard size, so the game doesn't take too long. And
no, I don't think it's a matter of board size.
I hope not, because then it's a little bit of a step forward from 1997.
Because if you mean like if I know in advance the size, then I can pre-populate all the possible scenarios that are playable. This is what you mean, or this is the rationale? Actually, no. Chess, for you to populate all the possible movements on a chessboard, it will take you, like, the total number is I think more than the total number of stars in our universe.
Well, that doesn't matter. It doesn't matter how big it is, as long as there is enough space for it to crunch and compact it. It's just a matter of compressing.
It's a matter of pattern recognition, knowing, because no matter how big your board is, if the same pattern is done on the top right of the board or bottom left of the board or center or wherever, you just have to be able to recognize that pattern and know that this pattern will lead to either a win or a loss.
But then when you get bigger, you start to need to find bigger patterns. You know what I mean?
A bigger pattern will probably be a copy of small patterns.
No, that's not how it happens. The bigger patterns, you need a pattern recognition on top of recognizing different patterns that grows up in a pattern way. It's like a. You can try this with a simple game. That's you draw a straw, and then 3 straws, and then 5 straws, and then 7 straws.
Yeah. Yes, I understand that. It's called fractal. Basically, it's a fractal.
Yeah, not really a fractal, because a fractal can be reduced to just one math pattern, but it would be a fractal within a fractal. It's like that movie.
Inception.
Yeah, and then you have to recognize the pattern that generates the other pattern, or that's an order of complexity bigger. So it's not that trivial to make an algorithm for that. And if it is really a smart algorithm that can really recognize patterns, maybe it can take that extra step for a bigger board. I don't think it can. I don't think we reached that yet.
Yeah, I see what you mean. But then, going back to the DeepMind Go, I think the game will be on,
It's pretty cool.
yeah, on March 9th. The program is called AlphaGo, and it will be taking the South Korean world champion Lee Sedol in a $1 million match.
Right.
And it's broadcast live on YouTube from Seoul.
$1 million is really nothing for the size of this event, but it's $1 million.
Yeah.
It's good. It's going to have pressure there, and the pressure is just at one side. Because the machine is not going to feel the pressure.
So what makes this different than like Deep Blue? So DeepMind and Deep Blue. Deep Blue beat the world chess champion Kasparov in 1997, and DeepMind hopefully will be the Go world champion of the world this year, 2016.
Yeah, if not here. Yeah, probably.
And because of the nearly infinite moves possible in the Go game, DeepMind doesn't try to calculate ahead like chess computers do. Rather, programmers taught the AlphaGo program the strategies used by Go masters.
Of course.
Yeah, so it's
That's not the way.
Yeah, it's not impressive, I guess, because it's still a supervised learning, but instead of learning from like all games, you just learn from the master games.
Yeah.
And also, they had the AlphaGo program play numerous virtual games to reinforce learning. So reinforce learning, yeah, this is the algorithm. So basically,
mixed supervised and unsupervised. Yeah, that's
yes.
perfect.
So no, not strictly supervised. So it's supervised at the beginning, at inception, let's say, and then it will play some virtual games where it sometimes wins, sometimes loses, and then somebody will come there and kind of redial the knobs, to reinforce the learning, to fix the mistakes.
Yeah. That's exactly what I wrote on Basics on how it should happen. Because it's exactly like that. You have to be supervised and unsupervised at the same time. So
yeah,
it's
hybrid, kind of hybrid, exactly.
Yeah, it has to be.
So I gave an example earlier, like deep learning basically boils down to three kinds of learning. There is the supervised learning, which means that somebody has to sit down, and so you have your mind, your tool, your neural network. That's your tool. But it's not the entire part of the system. You still have to train the system. And to train the system, you have three kind of, let's say, techniques: the supervised, the unsupervised, and the reinforcement learning. The first one, the supervised, is probably the easiest one and the most used one, even by Facebook and Google and Microsoft and all these big, huge companies. They're still using the easiest one, which is supervised learning. And what they do is they sit down and they filter huge amounts of data by hand, like sitting down, and then pick up the best or the clean data, and then feed it to the tool, the neural network, and tell it, okay, learn that this data is this result. So, for example, you can get 1 billion pictures of cats, label them as cats, and then feed it to the neural network, telling it that, hey, these are cats.
Yeah.
So the neural network will learn all these variations and just learn that, okay, these are what I expect to find when I look at a cat. And then there is the unsupervised learning, which is still a big question mark until now in AI. And that is, yeah, and I gave an example. Okay, so I think this will be a good analogy. Like say, if a baby is born, its mind is totally blank. So there's nothing in its mind, zero, nothing. It's a new baby with a new mind, and everything is ready. So the mother would come and teach the baby, hey, this is a cat, this is a dog, this is an apple, this is an orange. And that's supervised because the mother actually supervises the baby into learning all these variations and how to differentiate between them. So this is a supervised learning solution system.
The big difference there between that learning and a computer is that it's not images, it's video frames with higher quality than, you know, so.
Yeah, actually, this is not the data type is not an issue because actually video frames are just images, you know.
Well, but it's much more data. So
yeah,
it's much more process.
Capacity, yeah, definitely. As computer, the capacity is. Let's say capacity is not our concern here. It's just, let's say we have infinite capacity and we can handle all amounts of. We have supercomputers that can calculate. Huh?
All right, that's just theoretical today, because right now the capacity it is a big problem, even for big data.
I'm saying hypothetically speaking, just
let's go there.
Yeah, to explain it, like what's the difference, and then there is the unsupervised learning, which is basically a baby is born, but it's an orphan baby. It has no mother. It has no guardian or guide to tell it, hey, this is an apple or this is an orange. You have to actually discover this for yourself. And this is cool because it's still an unsolved mystery, because the computer has to learn by itself, and it can learn wrong stuff. So it can look at an orange and just hypothesize that this is an apple.
Sure.
So
but
something.
They're never gonna be able to tell the difference if it's calling an apple, an orange, an apple, as long as it doesn't confuse it with an apple. You know, it's not gonna give any names. It's just internal, so it doesn't matter how it calls internally.
But it matters when it interacts with other entities. If other entities refer to things as a certain thing, and you have a different certain
yeah, it's going to be called AAAA, and then AAAB, and then AAAC.
Yeah, so there's
understand it.
Yeah, exactly. So this is the unsupervised learning, which is still unsolved until now. Nobody knows how to perfectly unsupervise a neural network into.
There is no way. There is no way. The only way to do it is if you supervise it with dictionaries and encyclopedias and the internet.
And that's what they're doing right now. And we come to the third kind of learning, which is the reinforcement learning, which is basically a baby is born, the baby has no mother, the baby is orphan, and then the baby learns some things, and it learns some right and some wrong. And then the baby suddenly goes to a foster home, where its foster parents will fix it somehow, will tell it, hey, what you thought was an apple is actually an orange. And then they reinforce the learning of the baby, and the baby will then, okay, now it will fix some things internally in the neural network, and instead of referring to an apple as orange, it will refer to an apple as an apple. And then the baby is released again to the streets, let's say, and then it will learn more things, right and wrong. And
that's oh my god, why do you complicate things so much? It's so simple. Continuous learning, that's the way to go. It just, since the beginning to the end, just continuously make supervision and unsupervision together mixed, and also add internet into the context. Let it read from the internet. and then supervise it. It's just making layers.
I'm just giving examples for viewers to actually understand what we're talking about. I know that you understand it.
Right.
Someone might not. So this is what I'm trying to say.
So try to show the whole complex scenario to see that's not that simple to make machine learn.
No, the idea is simple.
Well,
the idea is simple.
You just give three ways to see and to try to make a machine learn, and the three ways they all have many problems that the problems that we see today. Machines are not smart at all, even with all the data and all the processing power that we have. And that's because, as simple as it may look like, it's not. There is a lot of complex and different ways that we can try. They don't work.
Yeah, absolutely, and the variations come in many forms, but the basic idea is still the same. So you can't learn something without actually going through data. Yeah. This is whether in human intelligence or in artificial intelligence.
First, you need data, you need input.
Definitely you need input, and what I'm saying is the supervised learning has been solved. We have exhausted it. We have no issues with that. We totally understand the technique. If we have variations on that, then we can actually improve the tools, the neural networks, not the data.
Okay, that's what I mean. All right.
Unsupervised learning, pure unsupervised learning, is a total mystery. That's what I'm saying. It's a big question mark. Nobody knows how you can teach a computer without actually providing it data, how to make a computer learn by itself correctly. So this is why we go to the third kind of learning, which is reinforced learning, which is learn some, will fix some, and then learn some, will fix them. And most of the big companies, Google, Microsoft, and whatever, they're using the third type, the hybrid type, which is supervised and supervised under the name of reinforcement learning. So.
Okay, all right.
But the idea is, hypothetically speaking, if we're not talking about performance, if we're talking about infinite speed and infinite capacity, then basically it boils down, deep learning, I'm not saying AI, I'm saying deep learning boils down to these three kind of techniques.
Right. All right. That makes perfect sense.
The data can, like, the input data, the learning data is also a big, like, the tools, the neural networks are a big portion of the system, with many researchers working on this part of the system, many new advancements, mostly small advancement. The tools are still the same for relatively, like, for the last, I don't know, 5 to 10 years. So on this part of the system, some people are working. On the other side of the system, the data science, how to actually automate the process of capturing the data, filtering it, massaging it, cleaning it, coming up with the best data set, and then dividing the data set into a training set, a testing set, and an error set, all these. So this is also a domain by itself. It delves down from statistics, from AI, so what I'm trying to say, it's not, if you wrap your head around these clear concept.
Do you know more about unsupervised learning?
Huh?
Do you know? Can you tell more about unsupervised learning? Because I have some pictures in my mind that I don't see why nobody is doing it, and I think people are doing it, but I don't know. It's taking too long, you know. I think people are more afraid of going all in rather than not knowing what to do.
No, actually, yeah, we don't actually know how to do it exactly, because for us to discover what is unsupervised learning, we have to first answer this on a human level. How do we as humans learn? We still didn't answer this question. We know that we store memories, that our minds resolve patterns and use synapses and whatever to fire neurons. So we're trying to go that biological, like everything AI now, the top AI.
everything is neural networks, even
Yeah.
in our learning, and it's only layers of complexity on top of it. It's like the inception thing. You make a neural network out of a neural network, and then you compress it, and you make it
Uh-huh.
smaller so you can use it as labels and as files. The analogy is out there. Some people must have noticed it already, and I think they're just afraid of unleashing the demon.
Yeah, of course there is a concern there, but unleashing the demon, I think we still have, like, I don't know, maybe too many years until we start being concerned of what AI can do to us. But right now we're still taking baby steps to an unknown world that we really know nothing about. For us to know how we learn, this is a big question that we have to solve first. How do we actually, we know how that eyes filter the data and break them down into smaller and smaller pixels, and then does something called convolution and subsampling to find patterns within smaller parts of a picture and bigger parts of a picture. So we do understand that, and we created an entire neural network that is built around this concept, and it's the best computer vision neural network up to till today, the CNN, the convolution neural network. But then we still don't understand what happens to the data once it's inside. Like, once it passes your eye and goes inside to your mind, how is this entire process of segregating information, of saying, this information is new, so this, I should get a new hypothesis on this information, I should relate it to something I already know, and grab
Wow.
all the things that I already know and compare it to these things that I already know. Is it similar? Does it look the same? Does it feel the same? Because you have 5 senses. Does it feel? Does it look? Does it the color is the same? Does it smell?
It's much more than 5. We discussed that already.
Yeah. It's much more. But let's say, just to bring it
All right.
down to our
All right.
humble
So
level.
call it 7, just so people know there's more than 5, and there's nothing to do with the 6th sense.
Yeah. So yeah, we do definitely have more than 5 senses, but for the average viewer, let's just say it's 5: the smell, the touch, the hear. So we try to, so it's, you see, it's the point. What I'm trying to say is the complexity of the problem that happens after it actually goes to the neural network is something still undiscovered by us, for us to know how we learn, like how the primate human, the monkey human, let's say, how did the monkey human evolved from being a monkey human who is totally savage and illiterate and like clubbing everyone around him, to the modern age human, where he can research and use Google, and like this part is totally, we don't know how to jump our understanding from that human mind to the modern human mind.
I'm gonna agree with you, actually, because I had that mindset that I thought people were afraid, but you know what? Maybe some people are afraid, but of course there are a lot of people who either are not or just don't care.
Yeah.
And if they knew how to do it, they would have done it already. So I'm gonna agree with you. It's a lot more complex than it looks like.
You know someone by the name of Hancock, this is his last name, I forgot his name, but he's a famous British scientist who actually studies the work of medicinal plants like marijuana, like ayahuasca, yeah, all these good stuff.
Are you going there?
I'm going to the dark path. Yeah. So, and he actually claims, okay, that the jump in human intelligence from the primate human to the more
It's huge.
and the reason for that is actually hallucinogenic plants.
It could be.
So what he's claiming is that they ingested some hallucinogenic plants, and these hallucinogenic plants actually mutated or shifted the way human intelligence evolved through the ages. So here is what I want to just. I know you have a comment on that.
No, actually, this is a very good theory because it's very easy to verify it. You know, just give marijuana to monkeys. Let's see
Oh,
what happens.
or simulate the marijuana effect or the ayahuasca effect on a virtual level and feed it to a neural network. Just
But
get
to
get the
but
computer high.
simulate it? Because to simulate it, you have to reach a random state that's much bigger than we have today. No,
Yeah, yes.
you need much more
Random
random. Yeah.
state. Did you say random state?
Yeah, that's the whole point of hallucination. It's bringing on the random. You know.
Yeah, I think you're right here. Yeah, just feeding it a random number seeder and just
Yeah.
keep pushing this data. But the thing is, no, I don't think it's purely random. There is some pattern in that.
Where?
I mean, like, I
In
don't know. Yeah, and
hallucination.
hallucinations, you see pictures in your head, you can, like, I don't know, talk to people, you visualize stuff, and these have meanings and have messages within them. Randomness is like static, like if you open your TV and it's on static, that's random. That's like there's no pattern.
Yeah, we cannot recognize any pattern. That it doesn't mean there is none. That's the whole point of both random and chaos. We can only identify a pattern up to a point.
Mm.
And after that, it becomes random because we cannot recognize it. Doesn't mean it doesn't have any pattern in it. So computers can already identify patterns where we cannot, because they can crunch big data. And it's patterns in one-dimensional numbers. We are good for three-dimensional numbers, and then computers get lost in there yet. But there's a very, very good argument about random. When you can compress data, a lot of zeros, for instance, brings no information because you can compress it to 2 data points, infinite zeros.
Yes.
So it brings no information. Randomness is what brings information. It's what brings new. So when we cannot identify a pattern, it only means it has so much information in it that we can't digest.
Yeah. And chaos theory also, he brought up chaos theory, which is very interesting subject. And it comes back to also fractals and patterns within fractals, repetitive patterns. And fractals are actually a huge subject when it comes to compression.
It is. It is, but that's pure mathematic. It's as big as it is. It's also either outdated or very basic.
Yeah, no advancement in that field.
Yeah.
Very interesting. Very
as far as I know. Well,
huh?
I love this discussion.
Yeah, I know you love
it. Actually brought me ideas to Mariox. I have to add randomness.
Randomness I used in a research of mine. I used randomness, and
no, but I have to add true randomness. True randomness. I have to get noise from everywhere.
You see, the thing is, true randomness is no, you can't actually acquire true randomness.
Well, there's the complicated part, because now we're coming up to the philosophical part of whether the universe is deterministic or not.
Yes. Exactly, because what you see right now, if you generate a random number or a pseudo-random, because this is the thing, in all science researches and all papers, nobody refers to true randomness. Everybody says pseudo-random.
But I'm not talking about technical. I'm talking about true, real random number, like a dice playing or a thunderstorm or a butterfly flapping its wings and making a thunderstorm on the other side of the planet 3 30 years ago, 30 centuries later. I don't know, you know.
Yeah, but that is somehow not true randomness. That is determined according to the Big Bang, to whatever happened before the Big Bang, and that this is people. Oh, maybe some like the average layman would say, "Hey, this is true random. I got a 6 on my dice. Give me my $1 million." But actually, it's not true randomness. It's pseudo random. It's everything is. And like you said again, it goes back to deterministic versus non-deterministic of the world we're living in right now.
And you know what?
Yeah.
I came to the conclusion many times that the universe is deterministic. But recently, just this year, given the discoveries, the findings on quantum mechanics, that quantum mechanics is actually not deterministic, and that's where many physics today and the physics from today say that Einstein was wrong, that God does play dice. So basically, it's a new field. It's very, hypothetical, and there's nothing realistic on quantum that can connect to our universe. But there is a window there, 0.0000001% chance, I don't know how many zeros, that out of everything that's so deterministic in our universe, there's one little thing that might not be. And if there is one little thing that isn't, then nothing is.
Yeah.
So that's why it's so complicated to pinpoint if it is or if it isn't. And my current understanding, through a lot of experiences that I have gone through January, just this January, I changed my mind. I think it is not deterministic.
So this subject is very scary to me because it not only touches on this deterministic versus non-deterministic, randomness versus pseudo randomness, but also touches on the eventuality of the existential of God.
Everything.
Yeah, and, I don't know, man. I don't know. I just.
I don't know either. It's just a gut feeling.
Yeah, I reach a brain fart in when I reach this level, and I think like, yeah, man, let me just watch a Netflix episode and just relax.
Have you seen Unbreakable?
And yeah, you've talked about it, but and no, not until now.
The song is so funny because they made it an autotune, like a black guy singing and an autotune like it was on YouTube, and then he says, "Oh, it's unbelievable because they just went out of the bunker and there are 4 women alive, and no women ever came in this region. We smell no women, we saw no women." And then this black guy goes crazy about it, and then he says, "It's a miracle." It's so funny, and they made a sound of it, man.
Yeah. Anyway, I just want to, because we are broadcasting live actually right now. So
sorry.
It's okay. But it was really interesting, and just keep an eye on our hangout for those who are viewing us right now or later in the future.
All right.
And know that we do broadcast on a bi-weekly basis. So thank you all for watching. Thank you, Cow. Just hang on, we'll be there after we stop the broadcast. But then thank you all for watching, and see you again soon. Bye.
See ya.